Hey guys, welcome to the third part of the chain reaction game tutorial. We are making this with the Godot Engine. And in the last episode, we tackled the code for creating the spatial buttons that we told. And we are also currently printing the status of each button, that is the position of each button if it's not null in this process function. So I'll just hit play. And now you can actually see the output. Actually, in the last episode, my camera, my face was actually on the output. So now you can clearly see that this is printing properly. So the bottom leftmost is 0,0. And as we go to the right like this, it will be 9,0. And if we go to the top, it will be 0,5, which is the y-axis. And if it's in the top right like this, it should be 9,5. So it's working fine. And in this episode, I told that we will be going over making the atoms, that is popping out the atoms when we click on each of these buttons. So before we actually do that, it's better we tackle the data layer first of the game. So the data layer consists of all these spaces that each button is assigned to, and will also hold the number of atoms that are in that square. And when we actually explore that atom, when we press on it, it will split it into 4 pieces. That is, it will reduce the required number from that space, and it will add 1 to each of the spaces which are all around it. So this is the way we will be going over making this game. So 1 minute, I'll just open my references here. So yeah, so after we do this, we shall create a new class called space. So this class will hold what all the information that each space has. So I'll just declare a new variable called n. This represents the number of atoms in that space, and another variable for the color. So the color will assign it to -1 and n will be 0 by default. So I'll just put a comment here. So this shall be 0 for player 1, 1 for player 2, 2 for player 3, and so on. Right? So -1 represents that this doesn't have any color, provided that there is no atom in that space. And then color -1 is just the default value we are giving. And we'll also create an array called board data. So creating an array will assign it to an empty square bracket like this in Godot. That's the same way you do in Python as well. So this board data array will be a two-dimensional array. It will hold all the instance of this space class inside it. So this will be our main data layer. So I'll just make a comment, populate the board data array, right? So just to populate this, actually it's very simple. Just do a for loop for I in range, the small range, not the capital R. Range, okay. So range from left bound, that is 0, to the right bound, that is 9. Yeah. So we'll make a variable in here. We'll make another array. I'll just name this as BARR, like board array, smaller one. So it just initialize an array like this. So this array will be populated first, and then we'll add it to the board data array, that is over here. Right, so I'll make another for loop for j in range. Now this goes from up bound to the down bound. Alright, so we'll add an instance of the spaces class, that is the space class that is here. So barr dot, we'll use the append function, and the space class dot new. So this is the syntax to actually create a new object of the space class, and we will just append it to the board BAR, the temporary array over here. So now what we have to do is we'll have to board data.append. We'll append the smaller array into the big array. So append the array itself. So now board data should be a two-dimensional array after this statement. And now just for testing purposes, I'll make a new function which prints out this board data into the console. Alright, so as this is the data layer, we won't be knowing what is inside that layer. So often we need to print that out in a structured manner. So I'm creating this array to print it. So I'll just name it print board data pass. So inside this function, it is fairly simple. I just do a for loop for I in board data. So this I refers to the array now. So in here I'll just make a pair of parentheses inside which the array gets printed. So I'll first print an opening bracket like this, and next I will just print a closing bracket. So yeah, and in between these I will write for j in I, for each element in the smaller array we will just be printing out what is there. First I'll open it up with an opening bracket, and this will be j.n. Okay, so because j is the instance of the space, so messages here. Okay, so j will be the instance of the space that is inside board data. So it has got the property n, so we'll be accessing the property n, j.n, and also print j.color, so the color of that each atom that we're going to instance. So I'll close this bracket. Now after creating the array, I'll just print the board data. So just after doing this, I'll just hit play over here, and now here we should actually see all the board data. But yeah, it's printing null because I'm actually printing the state of the current button. So I'll just comment this out, hit play again. So now you can see that there are a bunch of zeros and minus ones getting printed. So this is actually working, it is getting instanced. So these pair of values are actually one instance of a space. Okay, so after we have done this, the next thing we'll do is handle the UI inputs. Alright, so we don't know, the Godot engine doesn't register, it doesn't know that the clicking of a button is an event yet, because we are only mouse overing the button. We have not handled when we click on it. So we should tell the Godot button to actually make an action for this, and action for the clicking of the mouse button. To do that, just go to the project over here in project and project settings, and here in this tabs, go to the input map tab, and here you can see all the set of something called actions. So these each sections over here, they contain a bunch of types of inputs, so that you can do the same thing with multiple types of controllers or multiple types of inputs. So for example, if you want to accept something, if there is, you want to just shoot a player by using enter, so you can use this UI accept. It obeys all of these, it takes input from all of these types of keys. So you can press enter. So this is the KP enter, that refers to the keypad enter over here, and this is the space. You can use space or the enter buttons to actually do the same thing. So that is very handy. So for a click command, you can see that I already made a UI click over here, so this won't be there for you. So just to create a command, just go over here in the action, just enter UI click and press add over here. So where is the window? So yeah, so here the UI click is present without any of the buttons assigned to it. So to add an event, that is a button, just press the plus button over here, go to the mouse button, and this will be the device 0, that is my mouse over here. If you have multiple mouses, you'll get device 1 as well. So I'm selecting the left mouse button, add. So here you have an UI click action with the left mouse button command attached to it. So now we'll close, and to actually get that action, to actually handle the mouse clicks, we should do that in the process, because every frame we are checking if the mouse is down, right? So just in if we will select it through the input class. So if input dot, so there are 3 basic functions over here. If you just press is underscore ac, okay, you will get 3 functions over here that are related to the action, because it is action, right? So the first function is action just pressed. So this will be called the moment you press down the mouse. So when you hit the click like this, so 1 frame it will be called. And then the second function is action pressed. So this will be called each frame the mouse is held down. So after you hold down the mouse, after the just press is called, the pressed will be called, because it will be called each frame the mouse is held down. So if you hold it down for 2 seconds, for all of that 2 seconds, this function will be true in the process. So in the action just release, which is the third function, when you release the button after holding it down, that 1 frame that you release the button, this function will be get called. So I think the most relevant function to use here is just released, because when you are actually holding down the button, if you hold down it for a long time, I don't think it is appropriate to actually so it's just a convention that you use release for when you release the button, you are confirming that it is actually clicked. So here it is asking for an action, so we just created an action called UI click, so we'll select that. So if this is true, that means the mouse button is getting released, the left mouse button is getting released on the button. So we'll also have another check if the current button, which is the vector 2, which will be set when you are mouse overing that button, this one over here, and we'll also check if it's not equal to null. If it's null, we don't want to process the input because the mouse is actually out of the grid over there. So if this is not equal to null, so I'll just hit pass for now, because this is when we want to handle. So this area of code is when we want to process that input. So I'll just make another function to actually process when you click on one of the tiles. So I'll just name this as explode, I guess. Okay, not explode. I'll just name this as button pressed. All right. So this will take in a position of which button you actually pressed. The position of the button we press now. So this button pressed can actually be called over here inside. The current button is null. Just press this button, and the argument we are passing is the current button itself, because it is a vector 2, right? So this position is a vector 2, which will get it from this function. So when you press on that button, what needs to happen? We should probably increment the number of atoms in that button, right? So to do that, we will just increment as one of the atoms. So you can access that by board data at this position that we got in the argument .x and at the position .y. So this is an instance of the space .n, right? That is the number of atoms, n plus equal to 1. So we'll increment 1 atom on that button which we pressed. So cool. The next thing we will do is we'll call something called as explode. Okay, so first we shall test if this is working. So after the button is pressed, we'll call the print board data. Okay, just after this button is pressed, just to see what is the status. So I'll just save the scene and I will hit play again. So it just prints out all of the layers in the data. So now when we actually go over here 9,5, so because there's the last ones, so I'll just click over here so that we can immediately see what is the status. So yeah, when we click over here, you can actually see that this variable, the last but one, is actually 1. So one atom is getting added to the last box over there. So if I click again, it should be 2. Yeah, so it's getting a while to print, but it is working. So if we press again, this should become 3. As you can see, it is incrementing. So great, this is working. So the next, we will check if that button has reached this equilibrium. That means if it's a corner, if I just play here, if it's a corner tile, if it has 2 atoms, it needs to explode into these 2. All right, so if it's an edge piece like this one, if it has reached 3 atoms, it needs to explode into these 3. And if it's somewhat in the middle like this, if it reaches 4, it needs to explode into 4 different places. So we'll check if each of these number of atoms in each square has reached its equilibrium. That means it needs to explode. So to do that, I'll just call the function explode, which I'm going to create. I'll just pass in the position itself to this function. So we'll create another function called explode. This is more appropriate to be named explode check, because if it's not reached its equilibrium yet, so it will also bail out. That means it doesn't explode. So the first thing that we need to do, we need to tackle 3 things inside here. So we'll just put pass 3 things that we need to tackle inside the explode function. I'll just magnify this. So the first thing is handling the corners, and then handling the edges, and handling the spaces in the middle. Okay, so handling the corners, this will be just a simple set of if-else statements. So if the position that we get, okay, pos.x is equal to the left bound, I'll just put in the bracket, or if the position dot y, okay, position dot x is equal to right bound. So the right bound minus 1, because right bound is actually 6 over here, but the array is, oh sorry, right bound is 10 over here, and the array only loops from 0 to 9, so that will be 10 spaces. So right bound minus 1, and so if it's in the left or the right edge, and if it's in the top or the left bottom edge, bottom space, topmost space or the bottommost space, so that will be checked by pos.y is equal to up bound, or pos.y is equal to the down bound. Cool. So if this is the case, this ensures that we are in one of the corners, one of the 4 corners. So cool, I'll just make a sub cases for all of these 4 just to keep it organized. So if position.x is equal to left, and if it's in the upmost, that means it's in the bottom leftmost. So that's the first one. If it is 0 and 0, so what we will do is, if it's in this position, we need to call explode here again, so to check whether that is getting exploded, I guess. So no, actually I'll just add 1. We'll just not explode it yet, but we will handle what the data layer goes to do. So that is the board data dot position dot x plus 1. So we need to add one atom to the right, one atom to the top if it's in the bottommost left. So the x plus 1, that is 1 to the right, and the same position dot y dot n, which is the number of atoms, plus equal to 1. I'll add 1 to this, the right space, and I'll add 1 to the top space just above that place. So pos dot y plus 1, n equal to 1. So we shall do this, but first before adding 1 to the both of these, we'll actually have to reduce the ones in this current space. So pos dot x and position dot y will minus it by 2, right? So because there will be 2 decreased on this space when it explodes, and 1 will be incremented on the top one and 1 will be incremented on the right one. So just do this case. I'll just copy this and put a else L, and then if. So elif is else if. So position if it's in the left, and if it's in the down bound minus 1. Just remember that. So if it's in the left and the top one, that is, we'll still have to increment the right one, but if it's in the top, we'll have to increment the down one, that is y minus 1. So again, we'll copy this 2 times like this. So if it now it fits in the right bound, minus 1, and also if it's in the right bound minus 1, and now if it's in the up bound for this first one, up bound, not minus 1 for this. So right bound and minus 1, right and the bottom one. So we'll have to do x minus 1 because it's right in both of these cases, and if it's in the bottom one, y plus 1, and if it's top one, y minus 1. So this is done for all of the corners. So we'll do the same thing now. After the corners are handled first, we'll do the same thing for the edges next. So I guess after this is done, we'll probably have to return, right? So I just hit return so that it doesn't execute the edges code. So if one of these conditions is true, that means you're in the corner. So suppose you put the whole edges part in the top, you'll handle only the edges. So the condition that is left equal to b will be true first itself. So we don't want that to happen. And yeah, if it's in the upmost and the leftmost, only then we want to handle the corners. So it's actually better to handle the corners first, which has the most number of conditions over here, and the edges, which gives a slight flexibility. There are more chances of hitting the edges piece. So after we return right away after we execute if the corner is here. So after this, we'll handle the edges code, which is either one of the 4 sides should be an extreme. So pos.x is equal to left bound, or position dot x should be equal to the right bound minus 1, or position dot y equal to up bound, or position dot y is equal to the down bound minus 1. Cool. So this is true when it's in any of these 4 edges. So even if one of these is true, it'll get inside. That means it's in one of the extremes. That means it's in one of the edges. So the first thing we need to do is the same thing over here. Take the board data. We'll reduce it by 3 this time because it needs to explode into 3 different places. And I'll just copy this whole thing. We'll modify this again. So inside this if statement. So if it's in the leftmost, so it just has sub conditions left, and I'll just copy this for the right, and if it's in up, it'll be this one, and if it's in the downmost, it'll be the last one. So we need to increment 3 spaces here, right? So if it's in the leftmost part, you have to increment the one which is right of it Okay, we'll go clockwise here. So we'll increment the one which is above it, that is y plus 1, x and y plus 1, and we'll increment the one which is right, and we'll increment the one which is down, that is y minus 1, like this. So I'll just copy this whole thing and I'll paste it over here. So if it's in the rightmost side, the same thing we need to do, y plus 1 and then the x minus 1 because it's in the rightmost side, and then y minus 1 which is down one. So the next thing is just copy this, paste it over here 2 times, and then this will be x plus 1 and x minus 1. So if it's in the up, that is the downmost one, you have to increment the right one, you have to increment the left one, and you have to increment the one above it. So it will be y plus 1 over here. So the last one will be x plus 1, and yeah, there is nothing in the y here. Just delete the ones in the y, else you'll get an error. So the right one, if it's in the down, that is the upmost, it's the right one, and it's the left one. We'll do it for the last one. The right one, the left one, and the one which is below, that is the y minus 1 in the middle. So the left one is incrementing the y plus 1, x plus 1, and y minus 1, that is the up, right, and down if it's in the leftmost. So if it's in the right, that will be the up one, y plus 1, x minus 1, the left one, and the down one. And if it's in the bottommost, that is up, so that is 0. The one which is to the right, x plus 1, y plus 1, and x minus 1. So, and to the down, that means to the up, x plus 1, x minus 1, and the y minus 1. So this should be alright. So just make sure that you have you're incrementing only one of these in both. So if it's like x plus 1 and y plus 1, you'll be incrementing the diagonal one, so that should not be done. So else we'll also do a return over here. So that means that when you handle the edges code, you don't need to go to the space in the middle. So else you don't need to have any conditions here, I suppose. So if there are any conditions we need to implement, no, nothing here. So what we will do is just increment this on all 4 sides, right? That seems logical. So we'll have 4 of these incrementing. So the first one will be the y plus 1, the x plus 1, and the y minus 1, and the x minus 1 for the 4th one. So cool. So after we just do this, now actually we are not checking for the condition whether it is greater than 2, right? Only if the data layer has the position which is greater than 2, only then we need to explode. So I'll also add another condition over here, and so the current space, which is the corner space, should be actually greater than or equal to 2 dot n to be specific. So board data dot n should be greater than or equal to 2. So the same way for the edges, I'll just put a big bracket over here so that one of these conditions are true, and also another condition, that is just copy this one, paste it over here. This should be greater than or equal to 3, only then we need to explode. So else I'll also have to put a condition over here, that is else the same thing, x and y is greater than or equal to 4. So I'll just select this whole thing and hit tab so that it will indent properly. So this will be the exploding code. So now if we need to test this after we hit explode every time, so cool, I'll just hit play and we'll just see if one of these tiles is getting exploded. So we're also, let's just check if the printing is working here. So when you press the button, it'll also print the board data, so that is cool. So I'll just press the top right button. Oh, there's some error. So object and int operand So yeah, we have to put a dot n over here. Okay, so we are incrementing the property n. So not incrementing, we are checking the property n if it's greater than 3. So also here the same mistake that I noted now. So it'll be dot n if it's greater than or equal to 4. So now if I just hit play, there should be no errors. So now these last 3 blocks, which are roughly the ones over here, are normal. So I'll just click over here. It should be 1. Nice, it's turned into 1. Now if I click on the same spot, this should turn into 0, and the 1 should be incremented on the ones which are adjacent to it. So I'll just press here. So it is actually not turning into 0, it's still 2. But we'll check if the spaces above and below it are getting turned into 1. No, they are not. So I think something is wrong over here. So what is happening? So when we hit the button pressed, we are incrementing 1 to the board data, and we are checking if this is exploding. So if it's to the top right, and if it is equal to 2, so board data should be minus equal to 2. So this should get run. So just for the sake, if it's printing late, I'll just cut this and paste it over here after we explode. Right, so now I'll hit play. So now if I press over here and go to the bottommost, it is actually 1. So the last one is turning into 1. And then now if I press again, this is turning into 2. So the position is getting incremented. So yeah, there is one error over here, that is down bound -1. So I'll just check if all the right bounds have a -1. I just select it, so it will get highlighted on all the instances of right bound in the code. So it's down bound and right bound. I hope all of them are -1 over here, else it will be checking for the row below it. So just after doing that simple check, so now it's 0. I just hit, it should become 1. And now if I press this again, okay, so it is going into this condition, as you can see, because it's giving an error inside this condition. So I'll just hit .n. That is a mistake that I did. So it should be the number that we are going to decrement. So also if this is greater than 4, we're not decrementing this at all. So .n, this will be minus equal to 4. Cool. So I'll just hit play now. This should work fine. I press, it turns to 1, and I press it again. As you can tell, the last one is 0, and the last but 1 is 1. That is the one, I guess it is down of it. And if we go into the previous instance, there should also be a 1 over here. Yes, there is a 1 in the previous row. So 1 is getting changed, and also 0, this is getting turned to 0. So cool. So in the next episode, it's actually half an hour, so we'll be tackling the recursion. That means if the next button also is in an exploding state, suppose it's in an edge that you actually explode into, so that is also getting incremented to 3. So it also needs to explode and again add 1 to the next one. So we'll just tackle that until next episode. If you have any comments and doubts, just leave it in the comment section below. As always, thank you. Bye bye.